Our first one is we're looking for x. X is a side, so that means we're going to use regular old tangent. Because tangent takes a degree and spits out the ratio of the sides. So that's be tangent of 32 equals opposite over adjacent. To get x by itself, I multiply both sides by 83. And we're going to have x equals 83 times tangent of 32 degrees. And to the nearest tenth, what does that equal? Yeah, thanks. 51.9. Is that what number we got? I know it's 51 point something. I don't remember if it was 9 or not. Yes, perfect. Okay. Cece's got the next one.
Yes, I did.
Okay. What do I have to do?
Do angle A equals the inverse of tangent.
Yep.
And then 8 over 6.
And it'd be the opposite over adjacent, right? 8 over 6. And that's going to come out to about 53.1 degrees. All right, so when I'm looking for a side, we use tangent. When I'm looking for an angle, we use tan inverse. Yes?
Do we have to put the about sign, or can we just put equal?
Anytime we're rounding, you have to put the about symbol. So if you're not typing and you're writing exactly what the calculator spits out, which you probably can't because it's a whole bunch of decimals, anytime you're making an approximation, you put the about symbol. If it is exactly 53.1, then you put the equals. All right. Questions from the homework. Let's do that first. All right, solve that problem. All right, let's go into today's notes. Today's notes isn't really anything new. We'll have an example of an application problem that you'll have to pay attention to, and we're going to go through kind of styles of solving something. This is a bit new, though, because it does say take a tangent equation and turn it into a drawing. We can do that because we have tangent A equals 6 over 14. Tangent deals with right triangles. So the first thing I'm going to do is, okay, it's tangent, so let's draw a right triangle. Let's draw a right triangle since we're dealing with tangent. There is my right triangle. They also say tangent of angle A equals 6 over 14. So there must be an angle A. Here's the thing. You're never taking a tangent of 90 degrees. We're never using that in a tangent. So that means angle A has to either be here or here. It doesn't matter which one you call it. I'm going to do the bottom right one. I'm going to call that one my A. The only thing I really care about is that 90 degrees can't be the A. Because tangent never uses the 90 degrees. In fact, the tangent of 90 degrees is undefined. You wouldn't actually have an answer. All right, so I picked this as my angle A, but we could have did this one. Now remember what tangent equals. Tangent of an angle equals opposite over adjacent. Well, that means 6 is my opposite side, and 14 is my adjacent side. So we go to what I label this as A, and I say my opposite is 6, and my adjacent is 14. Now, I would like you have this method in your notes at least once. We did it yesterday, and we're going to do it again today. When I need to get A by itself, one way to do it is just realize that we use the inverse. We're going to use the inverse. So the mathematical way to do this is actually taking the tan inverse of both sides. That's how I'm going to get A by itself. So I'm going to take the tan inverse of both sides, left and right. I don't really have room to the left, so I'm going to put it all the way down here. So I'm going to go tan inverse of both sides. So I'm going to take the tan inverse of the left-hand side, which is tangent of A, is going to equal, I'm going to take the tan inverse of the right-hand side, which is that 6 over 14. That is how we can actually get a by itself. Because tan and tan inverses, since they're inverses of each other, they undo each other. It's kind of like one pushes and one pulls. If I push you and then pull you back to the same spot, you're where you started from. So since they undo each other, they cancel each other out. So that tan inverse and that tangent actually cancel each other out, and we're left with just a. And a equals the tan inverse of 6 over 14. But that's what we talked about yesterday. We said that tan inverse of the opposite over the adjacent spits back out our angle. So now we just need to plug that in our calculator, and we should get out about, I'm going to round to the nearest degree, and we'll go 23 degrees. So that is a picture, and it also solves the actual a value. Do you have a question? Yeah.
Do we have to solve for the other angle and hypotenuse?
Nope. It just says solve for the missing variable. You could though, right? I could add to this and say find both angles and find the hypotenuse. All would be possible questions that you should be able to solve. So me giving you tangent A equals 6 over 14 gives you a triangle you can solve for every one of those values, but you need to understand how to draw it. Does that make sense? You have to know how to draw that picture so you understand what's missing and what's not. All right, that's what we're going to do this one more time. It says tangent of 60 degrees equals x over 5. Well, once again, since we're dealing with tangent, we're going to draw a right triangle. With that right triangle, it says there is a 60-degree angle in it. It doesn't matter which one you label 60 degrees, but we know we can't label this as 60 degrees. That's the same reason we couldn't put A as at 90 degrees, because that's an acute angle. So this 60 degrees can't go here, but it can go here, and it can go here. It doesn't matter which one you pick. Just traditionally, I always pick the bottom right one. I don't know why. I just do. If you want to pick the top one every time, more power to you. If you want to switch it up every single time, awesome. All right, since tangent of angle equals opposite over adjacent, our opposite side is going to be x. Our adjacent side is going to be that 5. Well, this is kind of an easier one to solve for the variable because we just need to multiply both sides by 5. So if I multiply both sides by 5, it's going to look something like 5 times tangent of 60 degrees is going to equal x. Now we just type 5 times 60 degrees in our calculator, and we're going to come out to about, I'm going to round to the nearest tenth because it is a side. X should be about 8.7. Any questions on either one of those two problems? We're not going to spend a ton of time talking about those, but it's important for you to realize that if I give you an equation with tangent in it, you actually can draw an entire picture, and you can actually solve, just like Grant said, we could solve for a whole bunch of, we could solve the entire triangle. We could find this angle, we could find the hypotenuse, we could find that missing side. Yes?
You always want a decimal point on sides.
Read the question carefully, but if I don't give you directions like I don't here, usually to the 10th is a good thing. Even with degrees, usually around to the 10th, unless, because the homework said specifically around to the nearest degree. But if I don't give you any directions, the 10th is usually a good spot to just pick to round to. All right, the last one is we're just supposed to solve for y correct to the nearest degree. And the reason why I'm doing that is because the one before, I used tan inverse on both sides and actually solved it down here. A slight shortcut is to realize that if you're looking for an angle, we're using tan inverse. So that means I can jump right to the fact that y is going to equal the tan inverse of your opposite over your adjacent. So you don't need to show me all the work you did up there. You can just go, oh, Miss Baby, I understand the inverses are just the inverse of the side over the side equals the degree I'm looking for. So in this case, we can just plug that in our calculator and come up with y is about 30 degrees. I should put my about symbol, because it does say to the nearest degree, so I need to put it's just 30 degrees. Questions on either one of those two? 3. We did 3 of them. Ugh. All right, the last example we're going to go over has some new information in it. And you're going to have some of these problems in your homework. This one's talking specifically of grade of a road. The grade of a road is the ratio of its rise to its run and is usually given either a percentage or a decimal. But remember, a decimal and a percent are the exact same thing. In fact, they all go back to one thing we'll talk about in just a second. So the actual problem says find the angle that the road makes with the horizontal if its grade is 4%. So let's draw a picture of what they're actually talking about. So what they're talking about is we have a road that goes uphill. A positive grade is going to be a road that goes uphill. So this is our road. It's asking us to find the angle that the road makes to the horizontal. So it wants us to find basically what's this measure? We're going to call it x degrees. What is that measure? All they gave us was a grade. They said the grade is 4%. Here's the thing about percents. Percents are a placeholder for something we should already know is actually happening. Percent, per the word, cent means 100, correct? Because if you have a century, you have 100 years. If you have 1 cent, that's 1/100th of a dollar. Cent means 100. So percent, 14% means 14 per 100. Or it's 4%, I'm sorry, not 14. So 4% equals 4 per 100, or just 4 over 100. That's also what decimal means. 0.04 means 4 over 100. Everything goes back to fractions. We just have an easier way to write it than having to write a giant fraction every single time. So anytime you see percents, you should think about a fraction. So 4% really is 4 over 100. And it says that the ratio stands for its rise to its run. So that means that 4 is actually the rise. And that 100 is going to be our run. Yeah?
Can you reduce 4 over 100 to over 25?
You sure can. But we're going to end up plugging in our calculator, so it really doesn't pay to. The reason why I hesitate to tell you to simplify it is because what if you make a mistake simplifying it? And at the end of the day, we're plugging all in our calculator, and our calculator doesn't care if I plug in 4 over 100 or if I type in 1 over 25. So you can simplify it, but you don't have to. All right, so that's our rise over run. That means I'm going to go ahead and complete this as a triangle. And I'm going to make it a right triangle. Remember, this is a ratio. This is a ratio where for every 100, say, feet, you go up 4 feet. This isn't the actual distance of the road. Let's get that straight. This is just a ratio. So this might actually be 200 to 8. It might be 300 to 12. Or it could be somewhere in between that doesn't fit that ratio really well. This is just the ratio. For every 100 you go out, you go up 4. So the road might actually be here. We just need to figure out where that is. But they're not asking us for the length of the road. They're just asking us for this degree measure here. And all you need is a ratio to get your tangent value. So in this case, since we're looking for a degree, x degree is just going to equal our tan inverse of our opposite over adjacent. And that's why, you can actually do the 1 over 25. You're going to come up with the exact same answer. So if you plug in tan inverse of 4 over 100, if you type in tangent of 2 over 50, if you type in tan inverse of 1 over 25, you're going to get the exact same answer because it has the same ratio. And that ratio is going to wind up being about, to the nearest tenth, because it's a small number, I'm going to do 2.3 degrees. Lan, did you end up rounding it?
Yeah.
What'd you get?
2.3.
Crazy, right? So we don't care what those actual lengths are. We just need to make sure that that ratio holds, that 14% ratio holds. And that is our answer. That's a 2.3 degree road. It'd be going uphill about 2.3 degrees. Yeah, Cece.
How do you know when you're supposed to put the last parentheses in after the number that's in parentheses, the tan?
Can I see what you have?
Well, just like,
Typically speaking, you don't have to put that last parenthesis in your calculator. Your calculator automatically puts the last parenthesis in. It assumes you're going to mess up.
is there ever a time that you need to put it in?
You need to just keep track of when you have to use multiple parentheses. So let's say I'm doing tangent of square root of 23.
Okay.
When you open your square root, it's going to open a parenthesis. That one, you're going to be very careful to close it around that 23.
Okay.
All right? And when you need to really close it is if I do something else. So let's say I'm going to multiply this by 3. If I'm going to tack on times 3 over here, if I want it to be outside, I better make sure to close that parenthesis in my calculator before I do something else to it.
Okay.
If I'm not doing anything else to it, your calculator will just assume at the very end I'm going to close it off. It assumes you're going to make that mistake. Not a bad idea to constantly put the end parenthesis in so you get in the habit of every single time you're done with the tangent, you close that parenthesis in case you have to do something else to it.
So if you have a positive, like, whole number at the top and you're dividing it by a tangent, then did you have to do a second one after?
You probably wouldn't, if you're doing like, say, 23 divided by?
Or, sure, yeah.
Sure. Then you wouldn't have to close it because nothing else is happening.
Okay.
However, if I flip that direction, if I'm dividing by 23 at the end,
Then, okay.
your calculator is going to think it wants you to do all of that in one. You need to tell it, just do that as part of my.
Okay.
Does that kind of answer? I think I know what your question is. Does that? Okay, good. Any other questions? Yeah, hands up.
What do you mean, like, when you say the road doesn't go like 100 feet or like 4 feet up? Like, why can't it stop if it says the ratio is 4 to 100?
We just know it's got that ratio. We don't know that this is actually 100 feet. It's just if the road goes 100 feet or down below, then it needs to go up 4. But like Leanne, she reduced it to 1 over 25. So this would be 25 down here and this would be up 1. This is just a ratio of sides. I don't actually know any of these for sure lengths. But if I did know, if I found out that this length was 3, then this would have to be 75 to hold on to that ratio. So if we end up with something concrete, so these are kind of fluid. These are, if I could find that length, then I would know what the ratio is for this one. If I found out this one was 2, this would have to be 50 to hold on to that ratio. But all I care about is the ratio to get this degree measured here.
So you
And-
can change those numbers like however you want to make it the same ratio.
As long as it keeps the same ratio. Correct. Yep. So these aren't fixed. It's not saying that this road is whatever distance this would be if I did a squared plus b squared equals this. This road could be 100 miles long. As long as it preserved that ratio that, you know, every 100 miles it goes up 4 miles. Every 100 miles it goes up. It's kind of like, remember when you graph like a line?
Yeah.
You'd go over and up, and you would just draw it. That's what's happened to this road. This road can go on forever in either direction, just maintaining that ratio. So it's kind of a segment of a line that we're not going to put the arrows on because we don't need them. Yeah.
So how would you find the grade?
How would I find the grade? We would just go backwards. We would just, so we'd be given this degree, and then we use tangent to find, I don't want to do too much because that's actually in your homework. That is something you need to do. It's just doing this backwards. You are given a degree and you have to find that ratio. Other questions? Okay, the rest of the time is yours to work. Please ask questions.